Hello everyone, welcome to this video tutorial on reading Resistor's color code. Now, as explained earlier, one of the most important components in our Arduino robotics project is the resistor. The resistor is important because it helps in protecting our electronic component from exploding as a result of high voltage. Now, the chart below show how to determine the resistance and tolerance for resistors. The table can also be used to specify the color of the band when the values are known. For example, we could have 3-band resistor, 4-band, 5-band, and 6-band resistor. A 4-band resistor specifically has 4 bands. A 5-band resistor simply has 4 bars of different colors, and the same thing with the 6-band resistor has 6 different bars of different colors. Now, looking at the table, and we discover that in our table we have a column for first digit, a column for second digit, a column for third digit. We also have a column for multiplier and a column for tolerance, then a column for what we call the temperature coefficient. Now, if we have a 3-band resistor, it means that resistor has 3 bars. Therefore, to determine the value of that resistor, if we don't know the value, first of all, the first bar, which is the first band, the color of that first bar will be determined on the first digit. So you coincide the color there and the one on the resistor on the first. What is it? So in that way we map it, the first and second. Then the third one will be for the multiplier. Remember, 3 bands. First 2 for digit. First for digit 1, second for digit 2. Then the third one goes to the multiplier. Now, if you're having a 4-band resistor also, it goes this way. The first bar will go for the first digit. The second bar will go for the second digit. The third bar will go for the multiplier. And then the fourth bar, or what we call the fourth band, will go for the tolerance. Can you see? So it's similar. Now, but when we have a 5-band resistor, the first band goes for the first digit. The second band goes for the second digit. The third band goes for the what? Third digit. Can you see the difference now? Then the fourth goes to the multiplier, and then the fifth goes for the what? The tolerance. For example, now let's go more practical. A 4-band resistor which has the color brown as first, red second, green third, and then the gold color as fourth. Brown on our table, first digit is 1, so it takes the value 1. For second band we have red, and the red color on our table is what? Is 2, so the second digit now is what? 2. Now the third band is green, and remember this is a 4-band resistor, so we say that the third will go for what? The multiplier. So green under the multiplier is what is the value? The value there is 100k ohms. So it takes the value of what? 100k ohms. Are we together? Then the fourth band is gold in color. And remember, we said that when we have a 4-band resistor, the fourth band always goes for what? The tolerance. So looking at the color gold, what's the tolerance of the gold color? It's plus or minus 5. So it means that the tolerance is plus or minus 5. So we can have plus 5 or what? Minus 5 below the 1,200 what? Kilo ohms. Now the same thing goes for the 6-band resistor. For the 6-band resistor, let's assume, as displayed in our slide, the first band here is what? Red. The second is purple, violet. The next one is yellow. The next one is that's the fourth one is black. The fifth is red, and then the sixth is black. Now let's quickly do the calculation. Our red color, the first band now. Red color carries the value 2, so we record the value 2 as there. Now the second one is violet, and violet is what? Is 7th, has a value of, as in digit 7. So you put the second value 7, so we have 2 and 7. Now the third band also, remember 6 band resistor, so the 6th band is also the third band is also for digits. So yellow, and the color is yellow. So what's the value of our yellow in our digit is 4. So digit 4 goes for that. Now the next band is black. Now that's the fourth. Now remember, when it's a 6 band resistor, we said that the fourth goes for multiplier, the fifth goes for tolerance, and then the sixth go for temperature coefficient. Therefore, our black color under multiplier is 1. So it means we are going to multiply 274 by what? By 1, which is the same thing as 10 raised to the power 0, isn't it? Good. Now, the fifth band there is red. And red, our tolerance is what? Plus or minus 2. So it has a tolerance of plus or minus 2. Then the last band, which is black, has the coefficient, the temperature coefficients of what we call of 250 ppm per Kelvin. Is that okay? So that's the basics for our reading the resistor color code. However, there are certain tips that should guide us in doing this, because at times our resistor might be a bit complicated, that would be very difficult for us to determine where to even start the reading. So some general tips for reading the color codes are: 1, the reading direction might not always be clear. Sometimes the increasing space between band 3 and band 4 provide an indication of reading direction. Also, the first band is usually the closest to a lead, or that's a gold or silver band. The tolerance is always the last band. So it has in that context. So secondly, it is a good practice to the manufacturer's documentation to be sure about the color system use. Now the third one, when in doubt, measure the resistance with a ohm meter. In some cases, this might even be the only way to figure out resistance. For example, when the color band are burnt off. So you see, it will be very difficult for us to do that. Now, to memorize this table, there are so many mnemonics we can use. However, I want you to use this mnemonics which matches the first letter of each word to each color, which makes up the resistor color code by order of increasing magnitude. For example, bad boys ring our young girls, but Victor goes without. So bad B, boys B, ring R, our O, young Y, girls G, but B, Victor V, goes G, without the W, which stands for the color black, brown, red, orange, yellow, green, blue, violet, gray, and white color. Thank you for